Hello. Welcome back. You're gonna watch a video of me adding and subtracting polynomials. If you do not know what a polynomial is, you need to Google that real quick and get an idea for what it is. That's an O, polynomials. Gnome, N-O-M, sorry about that. All right, so adding and subtracting. Main idea here is that we need to look for things that are called like terms. Like terms have the same variable or variables, and they must be raised to the same powers. Good Lord, powers. All right, so for example, constants. 3 and -10, those are like terms. They both have the same variable, which is no variable. Okay? You can even think of it as like x to the 0th power. X to the 0th power is 1. How about x and -1/2 x and 3x? All of these have the same variable, and they're all raised to the first power. It's assumed 1 up here. We don't have to write the variable, but there's a 1 here. What's another example? 3x squared y to the 3rd, x squared y to the 3rd, -2x squared y to the 3rd. See how they all have the same variables, and those variables are raised to the same, individually to the same power. So x squared and y to the 3rd. Easy peasy. So here's some examples of not like terms. X and y. They're both raised to the first power, but they are different variables. X and -3. This has a variable, this doesn't. Now, why is this important? If you don't, pause the video and get these notes if you don't have them. Why is this important? It's because we can only add and subtract like terms. So when we say something like x plus y is x plus y, they're not like terms. We can't combine them together, right? If we have an apple plus an orange, we can't say we have 2 oranges or 2 orples or something like that. No, we still have an apple and an orange. Okay, now another example, what about x plus 2x? Well, we need to think about these things. That the exponents, I'm sorry, the coefficients tell us how many we have. Now on the Ed Puzzle the other day, I asked you a true or false question. The teacher told you to put a 1 here, and I said that this means that x equals 1, and over half of you said true. No way, man. X does not equal 1 here. We don't know what x equals. X is a variable. It varies. It changes. This 1 simply means that we have 1x, right? So this visually, this literally means we have an x, and we're adding a group of 2 x's. And when we combine all these together, we have 3 x's, right? That's all this 1 means. It's like I have a car. I don't say I have 1 car, I have a car. So you have an x plus 2 x's. That's all that means. It does not mean the variable is equal, or the variable is equal to 1. We don't know what the variable equals. Okay, super important. So one more example. Let's say we've got 3x squared plus 2x minus 1, and we are subtracting 5x squared plus x minus 10. So we are subtracting each of these things. We're distributing that. So it's 3x minus 5x. I'm sorry, 3x squared minus 5x. It's what? So if you have 3 and you take away 5 of them, you've got -2 of them. 2 x's and you take away an x, oops, that leaves you with just an x. -1 and you take away -10, well, let's go up here off to the side somewhere. 1 minus negative 10. Taking away negative 10 would be the same thing as adding 10. Right? You remember that? Two minus signs in a row cancel each other out. It's a positive. Taking away a negative is the same thing as adding a positive. So negative 1 minus negative 10 is, whoops, negative 1 plus 10. If you start at negative 1 on a number line, and you go up 10 spaces, so we go up 1 to get to 0 and 9 more, that's going to leave us at 9. So what do? We just looked at the like terms. 3x squared minus 5x squared, 2x minus x, negative 1 minus negative 10. If you have any questions, please message me or watch the video on Delta Math. It'll give you some further explanation.